there was a few kids in the other class that asked to record this, but your class is quieter, so I'll record it in your class. So we're doing this point here, and we're going to remember that we need the intersection of the perpendicular bisectors. So the other thing you have to know is a line equation. So y equals mx plus b is your best bet here. It's the easiest. Okay? So if I but I really want the perpendicular slope to the triangle. So, for example, over here, the red slope m in that problem, you guys, if you have a great picture, you can just count, and you can see that it's up 1 over 3. But I'd be really careful about relying on your pictures because you don't have a smartboard and the numbers aren't always integers, so make sure you can do both. Slope is the change in y over the change in x. So even though from that picture the slope is 1/3, we're really going to do 8 take away 4 over 8 take away -4. And this method would work even when your coordinates are integers. So your slope's 1/3 for the red line, the triangle side. Well, we want the slope of the perpendicular bisector, which would be this. So slope that's perpendicular, that's the opposite in sign. So instead of positive, it's negative. And it's the reciprocal. So instead of 1 over 3, it's -3 over 1. That's the perpendicular slope. And we're going to use that in this problem because we're finding equation of perpendicular bisector. So how am I going to find the midpoint, Jackson, of that line? What do you do for midpoint? Oh no, the microphone's down. I'm going to have to start all over, but not in front of you guys. How would you do the midpoint? Middle, average? Right. So like if I called this M, it would be 8 plus -4 over 2, 8 plus +4 over 2, which is really just um, 4 over 2, which is 2, 6. You see that? 12 divided by 2. So the picture is going to help you. Every time you do a step, you want to look at your picture and see if it's reasonable. Because there's so many steps, you don't want to get all the way to the end and have a totally unreasonable answer. Looking at the graph, it looks reasonable to go over 2 and up 6 to get there. So it looks like a reasonable midpoint. So I'm going to use that to get the perpendicular bisector because this green line goes through that midpoint and it has the slope of -3. So to find the equation of the perpendicular bisector, I'm going to find b using the midpoint. So 6 is equal to -3 times 2 plus b. So -6 plus b is equal to +6. So add 6 to both sides. And you get 12 is equal to b. So look at the picture again. I can't get all the way up to 12, but think about it. If this is 6, 7, 8, 9, 10, 11, 12, it looks like that green line's heading to about 12. So again, it looks reasonable. So my equation for the green dotted line then is going to be y equals -3x plus 12. That's the first equation. Just not recognizing my writing today. So that's this one. So you have to do the same thing for the other one. So Taz, what should I do first for the bluish purple line?
You should find the midpoint. Actually, no, you find the slope of that, of the side of the triangle.
Okay, yeah, so the slope over here of this triangle, so for M, right here, that would be 4 take away negative 4 over negative 4 take away 0. What is, so that's negative 2. And you've got the picture, right? So think about it. Down 2 over 1 looks good. Down 2 over 1.
Yeah.
Okay, so the perpendicular slope then, Josh? Opposite reciprocal. So instead of negative 2 over 1, opposite in sign is going to be positive and reciprocal.
It's going to be positive 1.
Right. And then, like Taz says, after you do this, what do you do, Taz?
You find the midpoint of the side of the triangle.
Okay, Amy, what's the midpoint? And that would be right here. Yeah, and so negative 4 and 0 divided by 2 is negative 2. 4 plus negative 4 is 0. Picture looks pretty good. That's the midpoint. So Claire, what am I going to do with the midpoint?
You're going to calculate the slope.
Got the slope. So this is the perpendicular line. How am I going to use the midpoint?
You plug -2.
Yeah, you plug negative 2 in for x and 0 in for y. And that's going to give you where the line crosses the axes. It looks like it should be about 1. Do you see that? It's giving me b. So this is negative 1 plus b equals 0. So b equals 1. So my line equation is y equals 1/2 x plus 1. That's this one. How are we doing on that? Am I blocking all the way over there? So Aki, what do I have to do to find the circumcenter?
You have defined where the 2 perpendiculars intersect.
Right, I have to find where the 2 perpendicular lines intersect. And that's not looking like integer coordinates. That's right here. That's the goal. Okay? So I have to set up a system. I have to solve the system y equals 1/2 x plus 1 and y equals negative 3 x plus 12. So Carson, what do I need to do?
Set them equal to each other.
Yeah, set them equal because they're both y equals. So 1/2 x plus 1 is equal to negative 3 x plus 12. Eveline, what happens next?
Then you subtract the 1.
Sure. Subtract 1. 1/2 x equals negative 3 x plus 11. At this point, you guys, I would multiply everything through by 2 to get rid of the fractions. Can you do that? Do you remember doing that last year? Like, it's quicker for me to do that. It's not required, but it takes the messiness out of this for a little bit. And then I'm going to add 6x to both sides. So this is 7x equals 22. And so that's x equals 3 and a 7. So look at the picture and see if it's reasonable. Over 3 and a little bit more. That looks reasonable, right? So far, so good. Have a reasonable start. So, Jossie, how do I find y? Well, I know that it looks to me like the centroid the circumcenter, what I'm trying to find is 3 and the 7, but I don't know the y value.
You would plug in low, or no, you would put in 2 for x and 0.
Because I want the intersection of the two lines, and I know they both have 3 and the 7th in common. So I have to find the y value. So I have to use the two lines, or one of the lines. Do you get it? Not sure? Ethan, do you?
You just plug in x.
You just plug in the 3 and the 7th, but where?
For x as in y.
Yeah, for x in either one of these. You can plug it into this one, y equals a half x plus 1, or you could plug it into this one, y equals negative 3x plus 12. Which one would you do, Rebecca?
Probably y equals 1/2 x plus 1.
Okay, so that's the one we'll do. So she's going to use y equals, so Jossie, do you see that?
Yeah.
Because 3 and the 7th is on both of the lines. So in place of the x, she's going to put this. How about if I write that as 22/7 instead of 3 and a 7. Y equals 1/2 x plus 1. So that gives me y equals 11/7 plus 1. Right, and that's 1 4/7 plus 1, which is 2 4/7. That's what y is equal to. So that would be hard to do by guessing, right? You need the algebra here. And then go back here, and it does look like it's about 2 4/7, because that's almost a half, right? That looks like it's close. So 2 4/7. That's the answer to the question here. That's what you will be tested on. You'll be given a problem, and you have to go through those steps with the coordinates. That's a coordinate geometry problem. So, the good news is, first, you're just going to solve systems tonight. Second, I'm going to give you a worksheet that breaks this down step by step. Find the midpoints, find the slopes, find the perpendicular slopes, find the line equations, find the system. So you have a plan. That's how you're going to practice. But today I wanted to go through the whole thing, so tomorrow you could just come in and try it. And you won't have a big listening day. You'll have a work day where you just go through the steps and try to logically reason them. I'll give you a worksheet. There's a lot of stuff. I'm going to record it. See if it record it.